The crankshaft, the heart of the engine, the origin of all motion. Hidden within the rough metallic exterior lies a meticulous manufacturing process that combines technological prowess with masterful engineering. The journey of crafting a crankshaft is a marvel of transformation, turning raw steel into mechanical masterpieces that breathe life into countless engines. It all begins with raw steel blocks. Each steel billet undergoes rigorous inspection to ensure that its quality and alloy composition meet stringent technical requirements. The skilled worker, with sharp eyes and deft hands, carefully measures and marks the exact cutting points, as even a millimeter of error can affect the crankshaft's quality. The billet is then cut using a mobile gas cutter, employing the intense heat of an oxyacetylene flame to slice the steel into precise blocks. Each cut is clean and decisive, like the strokes of a master craftsman. The steel blocks are now ready for the next phase of forging in the intense heat of the furnace. The steel blocks enter the furnace, facing the first challenge in their transformation journey. The extreme heat, reaching several hundred degrees Celsius, alters the steel structure, making it more malleable and ready for subsequent machine processes. The glowing red-hot steel indicates it has reached the optimal temperature. The experienced worker, with precise handling, uses a long metal rod to remove the steel from the furnace. After heating, the steel is primed for the forging process, where it will be shaped into the preliminary form of the crankshaft. The forging press, the giant of the workshop with extraordinary power, is ready to tame the red-hot steel. The specially designed die will mold the initial shape of the crankshaft. The forging force is calculated precisely, ensuring that the steel deforms uniformly and accurately according to the die. Each powerful stroke of the press begins to define the crankshaft's initial contours. Depending on the design and technical requirements, the crankshaft billet may undergo multiple forging stages with different dies to achieve its complete shape. From a solid steel block, the crankshaft billet is now taken on its initial form, ready for precision machining. The crankshaft's journey continues on the lathe. The hardened alloy cutting tool, spinning at high speed, will trim the shaft, creating a smooth, cylindrical surface with precise diameters. The spiraling metal shavings flying off are like dancing metal dancers, demonstrating the precision and efficiency of modern machining technology. Under the careful control of the operator, the crankshaft's form gradually emerges with sleek lines, ready for the next refinement steps. The lathe continues its work, meticulously machining the crankshaft's distinctive features, journals, crank webs, and counterweights with high precision. The dimensions, shapes, and positions of each feature are tightly controlled to ensure balance and stable operation of the crankshaft. Every millimeter is carefully measured to ensure that the crankshaft meets the stringent technical standards. The keyway, a critical component for power transmission, is precisely machined using a vertical milling machine. A specialized milling cutter, selected for its appropriate size and shape, is used to create a perfect keyway. The keyway's precision and surface finish directly impact the crankshaft's transmission efficiency. To increase the hardness and durability of the crankshaft's ends, the operator performs reinforcement welding, connecting metal components to create a unified and robust structure. The crankshaft continues its metamorphosis on the lathe. This final turning stage focuses on perfecting the surface, achieving the highest level of smoothness and precision in every detail. Each cut of the lathe tool, like a meticulous sculptor's stroke, removes excess material, revealing the hidden beauty of the metal. Time and effort are meticulously invested to create a flawless crankshaft that meets the most demanding standards. The next step is grinding the crankshaft to achieve a smooth finish and the highest level of precision on the surface. Grinding wheels with appropriate hardness and fineness gently removes sharp edges and tiny scratches, giving the crankshaft a perfect, polished appearance. The crankshaft is fully transformed, becoming shiny and refined, ready for the final inspection, dynamic balancing. Dynamic balancing is a critical step, ensuring that the crankshaft operates smoothly without vibration at high speeds. A modern dynamic balancing machine, using advanced technology, analyzes and precisely identifies any imbalance points on the crankshaft. Based on the analysis, the operator will make adjustments to eliminate any imbalance, ensuring absolute stability for the crankshaft. After dynamic balancing, the crankshaft moves to the assembly area. Auxiliary components, such as gears and nuts, are carefully installed to ensure precise connections, completing the crankshaft structure. A final inspection ensures that every detail is perfect, and the crankshaft is ready to revive the engine's heart. The crankshaft, a mechanical masterpiece, forged from lifeless steel by the skilled hands and creative minds of the workers. Meticulousness and dedication in every step have produced a quality product that meets all stringent requirements. The crankshaft, the soul of the engine, the source of energy for countless motions. From colossal industrial machines to everyday transportation, the crankshaft silently contributes to the world's dynamic rhythm. After undergoing complex machining processes, the crankshaft is now complete.